Okay, my apologies there. My phone decided to kind of pause the video without my knowing, but I didn't get very far without you all. So we did a little replacement to turn this into just a basic equivalent to y prime plus 15y equals 0 format. Integrating factor e to the 15x. So left side is a product rule, right side 0 times anything is 0. So the derivative of e to the 15x times w is worth 0. We'll integrate both sides. So e to the 15x w is worth c. So w is c e to the negative 15x. So that means u prime is c e to the negative 15x. So we'll integrate both sides of that then. So then u is, so this would be c over negative 15 e to the negative 15x plus c2. So recall y2 was u times y1, and y1, recall, was e to the 10x. So then y2 is e to the 10x by c1 over negative 15 e to the negative 15x plus c sub 2. So y2, we'll go ahead and distribute that. So that's c1 over negative 15. We're just going to choose these to end up being convenient numbers anyway. E to the negative 5x plus c2 e to the 10x. So e to the 10x, that's already covered under our y1. So we don't need this guy. So we'll let c2 equal 0. And we'll let c1 equal negative 15. So then y2 is just going to be our e to the negative 5x. So there's our other solution. So the general form for the solution would be y is c1 e to the 10x plus c2 e to the negative 5x. So c1 and c2 are arbitrary constants. So we found our second solution and sort of the general form of the solution. You might have noticed on that our u to the first dropped out of that one entirely. That is actually not a coincidence. That is something that happens for a very good reason. So for this one, I will consider y double prime plus p of x, I'll shorten that to p in a moment, y prime plus q of x, y equals 0. Same deal, we're going to let y2 equal u y1. Then y2 prime is u prime y1 plus u y1 prime. And y2 double prime, u double prime y1 plus u prime y1 prime. So that's product rule for this first guy. Product rule for the second guy, u prime y1 prime plus, now I'll leave the u alone, differentiate y1 prime, which is y1 double prime. A couple guys alike in the middle there. So y2 double prime, u double prime y1 plus 2u prime y1 prime plus u y1 double prime. So subbing those in, what we get. Y double prime, so that's going to be our U double prime Y1 plus 2U prime Y1 prime plus U Y1 double prime. So that's this first part. Plus P times, now we'll put Y prime in there. U prime Y1 plus U Y1 prime. And then plus Q times the original Y, which is U Y1, and we're equal to 0. Now we can certainly do a little bit of cleanup, a little distributive property there. So U double prime Y1 plus plus 2U prime Y1 prime plus U Y1 double prime, and then we'll distribute the P. So plus PU prime Y1 plus PU Y1 prime plus QU Y1 is 0. So all these pluses, and we see some cancellation. Here's why. We have U multiplied by Y1 double prime. We also have a U multiplied by PY1 prime. We also have a U that was multiplied by QY1. Y double prime plus PY prime plus QY is 0. Goodbye to all those. So then we just work with what's left, what's arrived. So we have Y1 U double prime plus 2 Y1 prime plus P Y1, each got multiplied by U prime, and we're equal to 0. Now we want to kind of get into this format where we have a coefficient of 1 up front, so we'll divide everything through by Y1. That'll give us U double prime plus 2Y1 prime over Y1 plus P, so Y1 over Y1 drops out, times U prime equals 0. Like we did on our more specific example, we can put in a little W substitution. W is U prime, W prime is U double prime. So we have W prime plus 2Y prime over Y plus B times W equals 0. So we find our integrating factor, e to the integral of 2y prime over y, little sub 1s on each of those guys, plus b times dx. So that is e to the 2 natural log y1 plus integral of p dx. So that is y1 squared times e to the integral of p dx. So we're going to hit everybody with the integrating factor. So now we have y squared e to the integral of p of x dx, or just p dx if you want to shorten it down, multiplied by w prime. And then we have plus y squared e to the integral p of x dx multiplied by, we had 2y prime over y plus p times w equals, and then 0 times anything is 0. So left side is a derivative, right side is a constant. So derivative with respect to x of, this would be a y squared e to the integral of p dx times w equals 0. So we will integrate both sides. So y squared e to the integral of p dx times w is worth, we'll just call it c1. We'd like to get the w by itself. So then w equals y to the negative second e to the negative integral p dx, and of course times c1. So then u prime is y to the negative second e to the negative integral p dx times c1. So then we integrate both sides of that. So u is the integral of e to the integral minus integral p dx over y squared. These are little sub 1s. Should have been leaving our sub 1s in this. And we have our just arbitrary constant c1 plus c2. So then u is equal to let's see, yeah, we'll keep that. Oh, my apologies. Yeah, we'll just pick convenient values. C2, we're going to drop that to 0. C1, we'll let that be just sort of an arbitrary constant for now. So then recall y2 is u times y1. So y1 integral, we'll let c1 just be a 1. E to the integral minus p dx over y1 squared times dx. And we'll pick the c2 to be, again, a 0. So this one is a formula way to get to the same thing. All right, so this one we'll consider x squared y double prime plus xy prime minus 36 times y equals 0. And we'll say that y sub 1 is x to the 6th. We're not in the right format yet if we want to use that formula. So we'll divide everybody by x squared. So y double prime plus 1 over xy prime minus 36 over x squared times y is worth 0 over x squared is still 0. So then y2 is equal to y1 x to the 6th integral of e to the minus integral. So our p of x is 1 over x dx over y1 squared x to the 6th squared times dx. Looks a little bit messy, but it is actually a lot faster than the previous method. So then this is x to the 6th integral of e to the minus natural log x over x to the 12 times dx. E to the minus natural log of x is a 1 over x. So this is then y2 is x to the 6th integral 1 over x to the 13th times dx. So this brings a 1 over x downstairs. So that's x to the 6th times negative 1/12, x to the negative 12th plus c. We're going to choose the c to be 0. So that is then negative 1/12 of x to the negative 6th power. Now for the general form, I just want an arbitrary c1 times x to the negative 6. So we'll drop this negative 1/12 and y sub 2, then we're just going to call x to the negative 6, so that when we want, if they ask for a general form, y would be c sub 1 x to the 6 plus c sub 2 x to the negative 6. So both of our solutions we can together. Now occasionally they'll ask us to use that previous reduction method to find both a second solution and a particular solution. So y sub 2, y sub b. So we'll do a y double prime plus 6y prime plus 5y is worth x, and y sub 1 is known to be e to the minus x. So since we want to find both y2 and yp, instead of letting y2 equal u y1, we're going to let the general y equal u times y1. So for that one, y is e to the minus x u, y prime, product rule, minus e to the minus x u plus e to the minus x u prime, and y double prime, product rule again. So e to the minus x u. So we differentiated this, kept that. Now we'll keep the minus e to the minus x and differentiate u, that's u prime. Then we move on to the product rule for the next guy. Minus e to the minus x, hang on to your u prime. Then keep your e to the minus x and differentiate u prime, that's u double prime. So y double prime, e to the minus x u, minus 2 e to the minus x u prime, plus e to the minus x u double prime. So we do a little substitution into the original equation. So we have e to the minus x times u minus 2e to the minus x u prime plus e to the minus x u double prime. So that takes care of y prime. Then we'll have plus 6 times y prime. So minus e to the minus xu plus e to the minus xu prime. So next up we'll have our plus 5y. Again, use a little imagination, pretend I had enough room. So 5 times e to the minus xu is equal to 0. So a little bit of distributive property, and then we'll get to some canceling. So e to the minus xu minus 2e to the minus xu prime plus e to the minus xu double prime. Now we'll distribute the 6. Minus 6 e to the minus xu plus 6 e to the minus xu prime plus 5e to the minus xu equals 0. So we have 1e to the minus xu plus 5e to the minus xu. And then we have minus 6 of that same thing. Those are all gone. We can factor in e to the minus x and give ourselves u double prime. And then I have a minus 2 and a plus 6, so a plus 4 of the u primes. We know e to the minus x is non-zero. So u double prime plus 4u prime equals, oh, my apologies, not 0 here. Copying error, my apologies, equals x. So equals x here. E to the minus x is also not equal to x itself. So we can keep on with this guy. Oh, have to hang on to him. E to the minus x equals x. So u double prime plus 4u prime is x e to the positive x. So we multiply both sides by e to the x. Little w substitution. So tossing in our w's, we have w prime plus 4w is x e to the x. So our integrating factor here will be e to the integral of 4 dx, which is e to the 4x. So everybody is going to get an e to the 4x. So e to the 4x w prime plus 4e to the 4x w is worth x e to the x e to the 4x. So left side is a derivative of e to the 4x times w. Just a product rule turns it into the previous step. Right side is now x e to the 5x. Iterate both sides. So e to the 4x times w is worth, and then we have a little bit of integration by parts here. So u is x, dv is e to the 5x dx. So du is the same as dx, v is 1/5 e to the 5x. So 1/5 x e to the 5x minus integral of 1/5 e to the 5x times dx. So e to the 4x w is worth 1/5 x e to the 5x minus 1/25 e to the 5x plus c. When we're searching for particular solutions, we can't just pick convenient values of c. We would have to actually work with those. And we're going to call this guy C1. We're going to actually have another integral coming. All right, so let's get this w by itself. So then w is 1/5 x e to the x. So e to the 5x divided by e to the 4x is e to the 1x, or just e to the x, minus 1/25 of e to the x plus c1 e to the negative 4x. But w, recall, is u prime. So u prime is 1/5 x e to the x minus 1/25 e to the x plus c1 e to the negative 4x. So we'll integrate both of those. And then our u is a little bit of integration by parts again. So we have a 1. I'll put the other u in quotes since this is not the same. It's just what we're used to using for integration by parts. dv will be our e to the x times dx. So du, quote unquote du, is 1/5 dx. v is e to the x. So 1/5 x e to the x minus 1/5 integral of 1/5 e to the x dx. So that is integrating this first part. Then we have minus 1/25 e to the x. That integral is exactly the same as it would have been before. Integrating c1 e to the negative 4x, we would have minus c1 over 4 e to the negative 4x. And we would also introduce a c2. So then y is equal to u times y1. And our y1 here, recall from the other page, was e to the minus x. So y is this times e to the minus x. So e to the minus x times 1/5 x e to the x minus integral of 1/5 e to the x is still 1/5 e to the x minus 1/25 e to the x minus c1 over 4 e to the negative 4x plus c2. Go ahead and distribute. So y is 1/5 x e to the x times e to the minus x. That drops out. These two guys are like terms. This is minus 5/25, so minus 6/25. And e to the x times e to the negative x drops that off. And then we have minus c1 over 4 e to the negative 5x plus c2 e to the negative x. So things that had arbitrary constants attached to them, those are the y1s and y2s. The rest is our particular solution. So yp for this one is 1/5 x minus 6/25. Y sub 1 was our e to the minus x. That was given at the start of the problem. So that makes y sub 2 the e to the minus 5x. So if they're writing the general solution, they would just call this part circled here in red a plus c1 instead of minus c1 over 4. They would just call it a generic c1, not the same c1 that we got messing around with the constant there. All right, so from section 4.2, I would recommend 1 through 19 on the odds. The first batch says use either the reduction or the formula. The first handful of them are not bad either way. A couple towards the end of that, before the next little subsection of problems, get a little hairy using this method. I would go with the formula for them. And then the last few problems where they give you a particular solution, you would need the reduction of order anyway. So if you have any questions, please get in touch. Otherwise, I'll see you next time.